Do you like games? In this video series, you're building your own tower defense game. In this video, you will limit the range of your tower to add some strategy to where they get placed on the screen. Welcome to Game Titan. If this is your first time here and you want to learn about programming, games, or Scratch, start now by subscribing and clicking the bell so you don't miss anything. I made several mistakes in the creation of this video. I'm leaving them in because this is how coding really works. Keep an eye out for them, and see if you can spot them before I call them out. Leave a message in the comments if you do. At this point in the series, you only have one type of tower. If you start limiting its range now, you might accidentally make it harder to add a new type of tower in the future. So this is a great opportunity to make two different types of towers. Let's add some more costumes to your tower sprite. Name them with a convention like this: tower, hyphen, type of tower, hyphen, costume number within that type of tower. This will let you create a set tower costume function like this, which will be able to look up the correct costume for any of your types of towers. We won't use the costume number in this video, but we can use it later to animate the towers. Try the function out by calling it. You can see that the costume changes correctly. Last time the tower sprites were large. You can make them smaller if you want. Each tower clone will need to keep track of which type it is, in a local variable, for this sprite only. This is so that different towers can have different behavior based on their type. Add a new parameter to the cloneMyself function called type. Set the type variable to the parameter's value, so each newly created clone gets a type based on what's passed into the cloneMyself function. Call the new setTowerCostume function in the tick handler. Now you can play around with specifying what type the tower is when it's placed, like this. Wait, what happened? All of the existing towers changed type at the same time. We don't want previously placed towers to change, just because you add a new one. Pause the video here and see if you can figure out what the bug is. Leave a comment if you do. Remember from last time that clone level 1 are the towers in the field. When they clone themselves, that new clone becomes their laser. The cloneMyself block that's running when a tower is placed onto the field is the one that's running inside clone level 0, the original sprite. You didn't build a naming system for the projectile costumes yet, but you can switch this to say laser to get ready to do that later. Now when you call cloneMyself with different types, towers get placed of the correct type, and they don't change the previously placed towers. So, it's time to move on to limiting their range. Just like with type, you can add a new local variable called range. Each tower clone will have its own copy of this variable, so that each tower in the field can have a different range. Like before, let whoever is calling cloneMyself pass in a value for the range that they want, and set the range variable based on that value. It's always a good idea to test your code often as you go along, so you can add some say blocks to display the range. But the little Pico tower isn't saying anything. Why not? Pause the video again and see if you can figure it out. This was difficult for me to understand, so I added some logging. You can see that the range is blank. This isn't what I was expecting since I had passed 150 in. Pause the video again and see if you can figure this out with the extra information. The problem is in the cloneMyself function. When the tower cloned itself to become a laser beam, range got set to the empty string. Then, afterward, the tower didn't restore the earlier value for range. In Scratch, if you say an empty string, nothing happens. This type of thing happens a lot in coding, which is why it's important to test your code frequently as you work on it. Create some previous range and previous type variables. Save the old values of range and type in previous range and previous type. Then, set range and type before you actually create a clone. After you create a clone, reset range and type back to the saved values in previous range and previous type. Yay! The say blocks are showing the speech bubbles. Although the range variable was intended for the tower, each laser beam also inherited a copy of the variable. So you can use that to count down how far the laser has to go before it reaches the end of its range. Each time the laser moves some amount, subtract that amount from range. When you use the same value more than once in your code like this, it's a good idea to make a variable for it. Since the speed of the laser isn't going to change during the game, you can make the variable name all caps, like speed laser. Now, you'll want to delete the laser clone if its range drops down to 0. Remember to initialize speed laser so that clicking the green flag always brings it back to the same value. Your range limit is working! Let's add a partially transparent circle so that players of the game can see the range of the tower as they're choosing where to put it. To make it easier to see, pick a dark background for your stage. Different towers have different ranges, so you need to be able to control the size of this circle. Instead of having your code try to call the set size block on the circle directly, make a variable which will always store the desired target size. You can call it range indicator display size or something like that. Later in the tick handler for this sprite is where you'll actually call the set size block. You want the circle to be transparent, so make a variable for the level of ghost effect. One thing that the tick handler makes it easy to do is test out different values of ghost effect quickly. Just put the set ghost effect block inside of tick and adjust the slider. Maybe something like 53 looks good for you, maybe something else will. Here I'm just picking a different, flatter looking background that matches the fact that the range indicator is a perfect circle. Have the circle go to the mouse pointer and tick. If it's off-center like this, you just have to go and center the costume. At this point, make sure the circle is exactly 200 by 200 scratch units in size. This will make sure that the radius, or the distance between the center and the edge of the circle, is 100 scratch units, which will conveniently mean that 100 size is the same thing as 100 range. 50 size is 50 range, and 200 size is 200 range. We will need a way to turn this range indicator off later, so add an if statement that says, if range indicator display size is the blank string, then hide. Here's how you can test that the blank string is considered to be less than 1 by scratch. Otherwise, you can show and set the size like we mentioned before. Keeping this code simple is why we were so careful to make the circle exactly 200 by 200 before. Since Ghost Effect isn't changing throughout the game, you can move it into initialize so it doesn't keep getting called and tick and slowing down your game. Looks like everything is working. Let's show the original tower sprite that will eventually be in the shop and have it follow the mouse. This will indicate that it can be placed on the field. Later, when we implement the shop, we will need some variables to keep track of the type and range of the tower that's currently being held onto by the mouse. You could name the first one currently dragging type and update the costume of the original clone level 0 sprite accordingly, so the player knows which tower they're going to get if they click. Set the clone myself type to whatever is in this variable too. You'll do the same thing for range. Make a local current dragging range variable for this sprite only, initialize it, pass it into the clone myself call when a tower is placed on the field. Then the original sprite can also update the range indicator display size variable so that the transparent circle size gets updated too. You can test this works by adjusting current dragging range and seeing that the range indicator display size changes too. When you place a tower with a larger current dragging range, you can now see that it's firing further than the other towers. There was one more thing which caught my eye. You might have noticed it too. The laser seemed to be firing past the range circle for the 400 range sprite. If you experiment with this more, you'd notice that the size of the circle in this case is capped at 270. You can add some code that prints out an error message using the say block if someone tries to set the range larger than that. This type of code is called defensive code, and writing code like this is a good habit. So there you have it. If you like this video, please press the thumbs up button and support more videos like this one by subscribing to the channel and turning on the bell, and watching some of the other Game Titan videos on programming, games, or Scratch. Thank you for watching, and see you next time.